everyone. Today I'm going to talk about mechanical wave. There are two types of wave, mechanical wave and electromagnetic wave. Well, mechanical wave need a medium to pass the energy like sound wave, ocean wave, and seismic wave. And electromagnetic waves don't need a medium to pass the energy like the light wave, radio wave, and microwave wave. Three types of mechanical wave. Well, there's longitudinal wave, transverse wave, and there's surface wave. Well, they're different in how they travel. Okay? Longitudinal wave. What is longitudinal wave? The vibration of the median of a longitudinal wave is in the same direction as the wave. What that means, like in this picture, you can see the fingers move back and forth while the vibration, or you can say the wave, just travels back and forth. Okay? Okay? And it's just like a domino there. Dominoes are one like that. But okay, it's like a domino, but not domino pizza. Okay? So domino is different to domino pizza. Okay? And each domino falls at the same direction. Because the motion, like if you just do left and all the dominoes just go left direction. Like a sound wave, we know. And a sound wave, okay, the high and low pressure of the zone move both forward and backwards as the wave moves through them. So they just move like that. Okay. Compression and rarefaction. Compression and rarefaction happen when occurs, or it can happen when in longitudinal wave. The first thing you can find, okay, well, this compression is the coal are crowded together, and the rarefaction is very loose. They just separate a lot. What is transverse wave? Transverse wave, the vibration of a median and the wave are perpendicular. Your hand just moves up and down, but your wave just go forward. Just go that direction, so they are perpendicular. This and this are perpendicular, right? Okay, like a long rope. Then your hand moves up and down, and the wave just travels from this end to another end. Okay, surface wave. What is surface wave? Well, the surface wave is just travel on the surface like a ocean wave. But the surface wave includes both the up and down and back and forth. So it also includes the transverse wave and longitudinal wave. So if you add transverse and longitudinal wave together, you get surface wave. Like that. They move up and forth and back and forth, up and down, back and forth, and then becomes circles. So it looks like that. Circles. What is amplitude? Amplitude is the maximum distance that the medium moves from the resting point to your highest or lowest point. In longitudinal, in transverse wave, the highest is the crest. The highest point is the crest. The lowest point is the trough. But in longitudinal wave, the highest is the, maybe you can say, the compression, and the lowest is the rarefaction. Like that. Okay. So this is the amplitude, the distance. So the higher the crest are, the greater the amplitude is. Wave amplitude. Well, we know that I talked like before. The longitudinal wave is just, well, actually, the longitudinal wave is just how compressed it is are. It's just like if it's very, very compressed, then it will be a very, very big amplitude. Then if the sound wave will be very, very loud. Okay, so if it's very close together, it will be a great amplitude. What determines the wave amplitude? Yes, what determines? Well, it determines like the energy that the medium is disturbed. Like if you like that, it's a rope, you just do like a very big energy like that. It would be a great amplitude. But if you do it only like that, it will be a small amplitude. Okay, so if you do like that, the rope may have a big disturbance on the rope, but if you do that, it will have only a little bit of disturbance, like that. This is very big amplitude. This is only a small amplitude. Wavelength. What is wavelength? Wavelength is from the crest to the crest, or trough to the trough. Or you can say or you can just say another, like the rarefaction and compression. Okay? So the wavelength is from here to here, or here to here. Well, actually the distance is same. Okay? In the same amplitude, then all is the same amplitude. Shorter wavelength have more energy. So like that. In the same amplitude, you just like that. What's only that? We know that it has a less energy, but that need a lot of energy. What is frequency? Frequency is how much wave that happen in a given time. We always measure in 1 second, and we measure in hertz. Okay. What is medium? Medium is a substance that the wave travel through. Water is the medium of ocean, while the air is just the medium of sound. Well, we know that like that. In mechanical wave, the sound like sound, okay? Sound travels through solid, greater than liquid, greater than gas. All the mechanical wave is sound, but electromagnetic wave is different. It's gas bigger than liquid, bigger than solid, and it can even vacuum place, because that anything is just a block. Like maybe when there's no air, the light can travel very fast. By the way, so maybe like iron, they can even not travel. Wave speed. Wave speed is how far the wave travel in a given amount of time. Okay, like we know that 1 kilometer per hour. That means that you can go the distance is 1 kilometers, and the time is 1 hour. That means, okay, the wave speed depends on the medium that travel through and the speed. Okay, well, above this is one rope, or just a rope. If you do like very fast, it will just the same speed. But if you do very slow, it will be the same speed. The same medium will have the same speed. So all the voice have the same speed in the same air. Just the same. So anyone like that, they will be very fast, but all is the same speed. It's still very fast. Okay. So there's an equation. V is equal to lambda f. So that means v is the velocity, is the speed. The lambda is just not lambda. Okay. Lambda is the wavelength, and the frequency is the f. This example, consider the ocean wave as have the wavelength of 3 meters, and the frequency is 1. So just 3 is a lambda, 1 is a f, and then you times them together is equal to 3 meters per second. Okay, there's a all the waves in sketch below have the same amplitude and speed, which has a longest wavelength, which has the highest frequency. Well, A have the longest wavelength, we can just see it by our naked eyes, right? So it's from the crest to crest, or trough to trough. You'll see this distance is greater than this distance, and greater than this distance, greater than this distance, greater than this distance. So there's the trough to trough, okay? So the answer is A, which has the highest frequency in the same amplitude and speed. It's the same rope, okay? Wait a second. Okay. Well, in the same speed and amplitude, we know that longer wavelength has lower frequency, while higher wavelength has higher frequency. So the answer is E. Wave interaction. Well, there are 3 kinds of wave interaction: reflection, refraction, diffraction. Reflection is the first picture we can see. This one is reflection. This is refraction, while this is diffraction. Well, the first one I'm going to explain is reflection. Okay? Reflection reflection occurs when the wave bounces back from a barrier that they can pass through, like maybe it can happen in any kind of wave, just mechanical wave or electromagnetic wave. Okay, so the incident ray have the same frequency and speed as the reflected wave. Okay, like that. So just different direction. One is come from this direction, one is come from this direction. Reflection. Reflection. Okay, then which will be like a wave strike a wall in an angle. Well, why is it in an angle? Because then if you just strike, maybe you just it's perpendicular to the wall, so the bounce back will be the same. So it's the same, just different direction. Okay, so we call this ray goes in, and this ray is called the incident ray, and this to the normal is called the angle of incidence. Well, the red angle is called the angle of incidence. Well, this is the normal. What's the normal? Normal is the thing that is perpendicular to the wall, okay, or the barrier, okay. And this is the angle of reflection. It's just same to normal, but there's a reflective ray. And the angle of incidence is same as the angle of reflection. Yes. Well, remember, we already tell us this to the normal and the incident ray to the normal, not the reflected ray to the wall and the incident to the wall. But we just call that no. Okay, wait a second. Okay, so we can find. So although we know that this is equal to this is 0, but we always talk this to. Refraction. Refraction occurs when something that any kind of wave will travel through another medium that have a different speed. For example, here is the glass. Wait a second. Here, I will put a straw inside. It looks like sometimes you can find it's a little bend. Okay? Well, actually, it's a little bend you can find. Okay? You can find just this picture. No, okay, so why? Because the speed are not the same. Okay? So, like that. Maybe there's the carpet, there's the floor. First, the car just get in here, in this direction position. When the car is right here, this wheel is already at the carpet, while another wheel is still at the floor. So this is faster than then he will just bend, turn another direction, right? This direction. And now you from carpet to the floor. Well, no, when you're at this position, you find this wheel is still at the floor, while another wheel is at the carpet. So it will just bend right here. So you can find to the quicker place to maybe to the carpet, so it's slower. You'll find they will well, no, if you keep doing, if this is the whole floor, it will just keep doing like less, but it just go to the normal, so it's closer to the normal. Well, but in this position, I find that usually it's going to be like that, but it just go leave the normal. It's farther to the normal. So, what is refraction? Well, refraction, okay. Well, see, the sine. There's an equation they found. Is sine theta r. We can find this figure. The sine theta r over sine theta I is equal to their velocity ratio and their wavelength ratio. So what is sine? The sine theta r is a over this. Sine theta I is a over c. So we can find. We know theta r the angle is greater than theta I, and then find the sine is greater. So the bigger angle you have, the greater sine you have. Refraction. Okay, next example. Water wave have a wavelength of 3 meters and the speed of 60, and they just strike at in some things, okay, some maybe shallow water at 55 degrees, 53 degrees, okay, and then the new ray that is already refract, okay, is 30 degrees. So what will wave in the shallow water, the speed, okay, and the wavelength. Okay, so how to do it? They already tell you. Sine 15 is equal to 0.5. Sine 53 is equal to 0.79. Okay, so we know that sine theta r over sine theta I is equal to their velocity ratio. So this is equal to this because they already tell us, and you can just cross times. So the 8 is equal to 0.79. Well, 0.79 you could just do it equal to 0.8 instead. So you can find the answer is 10. So V is equal to 10. The first answer is 10. The second, their lambda. What is the same with just? It's 0.5 over 0.79, but it's lambda over 3 because there is 3 meters. So we can find one thing. So it's just cross time. Well, actually it's the same thing. So 1.5 is equal to 0.79 lambda. Okay, so it's equal to 0.79 lambda. So you can find 1.5 divided 0.79 is equal to 1.89. So the answer is 1.89. Diffraction. What diffraction? Diffraction happens when there's something they pass through an opening or obstacles. Well, okay, and then the wave may diffract or bend. Sound wave, okay, we can find. The student can hear the radio, but he can see the radio. Why? Well, because that the sound has more chance to diffract than the light does. Okay? Now, how much does the wave diffract? It depends on 2 factors: the size of the opening or the obstacles and the wavelength. Okay? If the obstacles or the opening is greater than the wavelength, the diffraction is minor, so it's not very big. But if the obstacles or the opening is less than the wavelength, the diffraction will be major. You will find why the light can't diffract. You can't see the radio. Well, because that the sound is from 1.7 centimeters to 17 meters, the wavelength, okay. But the light is very small. The visible light is 400 nanometers to 700 nanometers. It's very small. So so often we can't see the diffract. What is interfere? Interfere happens when 2 waves move of the different direction. Okay. So, and sometimes they can affect the amplitude, right? And there's 2 kinds: constructive and destructive. What does constructive interfere? Constructive interfere like the crest meets the crest or the trough meets the trough. Okay? So, this is 1A and B, and this is A plus B. And then they just B go here, A go here. So this has a very big amplitude. This is the amplitude of A plus the amplitude of B will be the A plus B. But destructive. Well, destructive is different. It's a crest meets a trough or trough meets a crest. Well, it's different because they cancel each other out. Like A plus B, A minus B or B minus A, and then become, okay, it becomes like that. A flat or even less amplitude. Okay, you can find with that. Well, ready, go. Stop. Okay, the first one we need to find This is the wave A, this wave B. You plus them together, become wave C. So you can find this is maybe this, and this is, well, this is gray, that is green. You add them together, becomes gray plus green, like that. So just keep going, and then become smaller. So, well, what's this? Well, this is different. You can find. Well, then this A, this B, they move at different direction. We can find. This the crest means the 12. This the 12 means the crest. So they cancel out each other. They cancel each other out. So this A, this B minus A, like that. And then you will just come back and become big later. Okay. I hope they become big. Okay, so I'm going to the next page. Come back, okay? Okay, we can find standing wave. Standing wave happen when you just do one wave and the wave just reflects, and then it just meets with a new wave like that. Sometimes the crest meets the 12, sometimes the crest meets the crest. So sometimes it is destructive, sometimes constructive, so it will be like that. What's Doppler effect? Doppler effect, when maybe the sound source moves through you, or you move through the sound source, the frequency of the sound changes, so their pitch stands. Because higher frequency have higher pitch, while lower frequency have lower pitch. Because, well, this is a sound source on the bike, and you move through the bike. Well, maybe the bike is right at the place. This is a sound source. You move through the bike. Ready? Go! And you can hear it very clear. Well, this is the original sound source. Well, this is when you move toward the sound source. This is when you move away from the sound source. We can find. They have both 25 cycles. These have longer wavelength, they have shorter wavelength. So shorter wavelength have higher frequency in the speed, and longer wavelength have lower frequency. So it's lower pitch, and it's higher pitch, like that. Or why, I'm going to explain it later. Okay. And notice that the sound source moves through you. This is a sound source. Go! I can hear very clear that the sound become low pitch. So because why, I'm going to explain it first. Why? Well, this is a sound, so maybe this mouse is you, okay? This is a you, and here, okay? You will find it's a very high frequency, but when the sound moves over you, you can find it's very low frequency. Because that, like that. So you can find they have longer wavelength, they have shorter wavelength, so they have higher frequency, they have lower frequency. That's the why. So why? Well, I'm going to give you another video. You move through the sound source. Ready? Go. This is a sound source, and you can find. Go. Ready? Go. Find the first phrase. Well, this moves in the same direction as the sound, while another moves in different direction, opposite direction. So this stupid bike have more chance to meet with the wavelength, while this idiot bike has less chance to meet with the sound. So you can find until you get to 9. This is 9 and it's 24. 9, 24, 9, 24, 9, 24, 9, 24, 9, 24. 9, 24, 9, 24, 9, 24. Okay, we're fine. So it means they mean a lot of wavelength. This means a little wavelength. So they mean a lot of frequency. It means low frequency. So they have higher frequency, they have lower frequency, they have higher pitch, they have lower pitch.